Hey everyone, David Twyble here. Today I want to start a new series called Aerodynamics 101, and the first video here is, what is an airfoil? Well, this is an airfoil. An airfoil is a two-dimensional shape. It's not a wing. It's just something that we could draw on a piece of paper in 2 dimensions. Now, let's say you go find a technical definition or you ask an engineer, what is an airfoil? Find the textbook definition. You might get something like, an airfoil is an infinitely long wing. Well, I think we all know, practically speaking, there's no such thing as an infinitely long wing. So that's a bit of a dodge when it comes to being a practical answer. But what that answer is really getting at is something that we might call isolation. So imagine that we want to study an airplane aerodynamically. So we put it in a wind tunnel. But then we have lots of things happening. So we start removing parts of it. We remove the tail, we remove the propeller, we remove the engine, we even remove the fuselage, everything except the wing. Well, we still aren't down to the most simple, fundamental thing. That is an airfoil, because the wing has wing tips, it has rivets and seams, and other things that make it different or slightly variable along its length, and we just want to get to the most basic shape. Basically, get to the airfoil, that two-dimensional shape, and the airflow interacting with it. And that's why we're so curious about what an airfoil is. Now, let's think about it from a practical standpoint. What is an airfoil? Well, we could think of it kind of like a raindrop in terms of its shape, if we stand it up like this. Maybe something you saw in a children's book for what a raindrop looks like, right? So we have a rounded bottom end and a pointed top. And we call this rounded front end the leading edge, and we call the back pointy end the trailing edge. Now for study that we'll do later, we connect the leading edge to the trailing edge with a perfectly straight line that we call the chord line. But we also need to define the upper and bottom shape of the airfoil, and we call that the upper camber and the lower camber. And that word camber is very important, and we'll talk about that in next week's video. But for now, we need to know those 4 points: leading edge, trailing edge, upper camber, lower camber. And we'll come back to those many times over, but those are the main ways that we define an airfoil in terms of its shape. So why might we care about this as pilots? We don't know the exact maybe number or technical definition or technical name of an airfoil on any particular airplane, and we don't need to. But we do need to understand that the shape of an airfoil impacts how an airplane's wing performs, specifically how it performs, say, in stall, right? So we could have an airfoil that behaves well in stall, and we could have an airfoil that behaves poorly in stall. We could also look at an airfoil's behavior in icing conditions. Does it behave well or does it behave badly? These things are of intense interest to pilots. But most importantly, the reason we're so interested in airfoils is because they form the basis of all terminology that we have about airplanes. In a sense, it's sort of the first word in our aerodynamics dictionary. So if we don't know about airfoils, we don't know about airplanes. So we've got to study airfoils to learn more as we build Aerodynamics 101. So like I said, in our next video, we'll talk about camber and we'll dig more into how airfoils work. And until then, fly safe.